this is the funny thing about the AI infrastructure. Kubernetes is being used quite a bit in AI infrastructure for training, for inference. Right? It is very clear. This is one of the big breaks from traditional HPC, high performance computing, that high performance computing typically was batch oriented. The AI workloads are fundamentally different in that they have a lot more east-west traffic. They're trying to build large memory models. They have to share a lot of information between hosts in order to capture that type of larger environment. They have much more difficult and challenging network topologies to build for these systems, for training, definitely, but even for inference. And then even for training, storage, which people don't think about. And so it's incredibly important to be able to very efficiently store huge amounts of information, because every second you spend doing a checkpoint is time you're not spending doing training. And so all of these concerns really intersect in very challenging and interesting ways from a hardware design perspective. Each node in an AI infrastructure is in a specific place doing a specific thing, and it has a relationship with its neighbors, right? So it's not, you don't have a pool of AI workloads that you use where they're generic unclassified machines that you can just pull in. But for AI workloads and for virtualization workloads, each machine has they're really expensive, so you want to make them work. Each one of those machines has a specific network topology that fits in and works with its peers. And so you actually have to treat it as a much more static member of the cluster. And that difference fundamentally changes the dynamics of how you think about Kubernetes and clusters than if you were doing an app dev where the purpose is to have these very generic high turn rate machines that you can expand or contract. In an AI cluster, you don't contract an AI cluster. Capability as you possibly can, as quickly as you possibly can. So you're going to set up, run, and maintain that cluster to its maximum extent as quickly as you possibly can. And when you have to do maintenance on that cluster or any of the nodes, you're going to do that as fast as you possibly can and reset the system back to its bounds and run it. What you don't hear talked about as much is this idea that I've built that cluster. That cluster has an exact configuration and a boundary, and every node plays a part, and I have to patch and update and keep that whole system running as much as I possibly can, as fast as I possibly can. It's actually, now we're back to why it's such a different use case to do physical infrastructure.